Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video, well, we're going to take a look at the cost of poor quality. This is a continuation to a video that I recorded a couple of days ago. If you haven't seen it, go back, look at my channel, take a look. There's another video on the cost of poor quality. And what we're going to call this one, it's a slightly different subject in a way, because I'm not going to talk about the cost of poor quality. I'm going to phrase it in a different way, and we're going to call it the cost of variability, because that is what Six Sigma, that is what Total Quality wants you to get rid of. We want you to get rid of variability, and we're going to take a look at why variability drives your cost of poor quality and why it's very difficult to allocate that cost of poor quality to individual projects. So that's what we're going to take a look at. If you want to know more, this very debate, this very description is in my book, Drink Tea and Read the Paper. So if you want to see this, you want to read about it rather than watch this video, Drink Tea and Read the Paper, it's all in there. Also, if you want to leave some comments in the fields below about this video, that would be very helpful to the channel, so please do that. If you want to request specific videos about specific subjects, then please do that. This was a request from someone, so these videos are a direct result of someone leaving comments in the fields below. So please leave comments. That would be excellent. So let's talk about this, the cost of variability. Now what we're going to look at is the idea of four processes trying to produce an item. Now obviously if you were super efficient and you wanted to be super lean, what would you try to do? Well, you would try to create a situation where the products just flow through all four stages with very little stock, very little time in between, and that would be a super efficient, low cost way of producing these goods. But you have this problem. Okay, so process A, we want process A, let's say we want to produce, I'm going to say we want to produce 50 items per hour. Okay, so 50 items per hour is where we'd like the production output to sit. So we don't have though 50, 50, 50, 50, 50. Nobody does. That would be the perfect process. Of course, what you have is a process that does this. And maybe on the average, process A hits the 50. Yeah, and of course, then process B might have a similar pattern, process C, process D. And by the way, these numbers could, because the machine doesn't run effectively, so it could be maintenance related, it could be engineering related. This could be as a result of quality issues. So it could be that you've made 65 units, but 15 of them were scrap, and you've still made your 50. Could be that you made 50 units and 15 of them were scrap and you only made 35. So it could be a quality related issue, it could be an output related issue. It doesn't really matter, but it's having an effect. It's having an effect on the consistency of the output. Now if each one of these performs in that way, of course, we have a problem, because if process A decides to have a bad hour, just at the point when process B decides to have a good hour, well, of course, if you've got no stock here, process B cannot accelerate. Process B has to go at the slowest rate. It has to go at this speed, or indeed you get this problem. Process B is going nice and quick, but process C is going nice and slow. We have no stock here. Maybe we just have a simple conveyor linking these together. Trying to link all these automatic machines together maybe. Of course, what happens? Well, the conveyor backs up, process B has to stop, even though it's having a fantastic hour. Okay, so what happens is this whole system goes at the speed of the slowest machine, which tends to mean even though they're all going at 50, this is a very important point, by the way, even though all these machines are going at an average speed of 50, what will you get coming out the other end? Well, what you'll actually get is the slowest speed every hour. So actually you won't hit 50 on the average for the system, even though you're hitting 50 on the average for each machine. The system will go at the slowest speed for that hour, and you'll just drag the efficiency right down. So for no other reason, that's the first cost of variability. It just sucks capacity out of your system. So okay, what do you do to combat this? What would you do to combat this problem? Well, one of the ways, of course, is to put some stock in between. So what we could do is decouple these machines. Yeah, so rather than having conveyed together like this, what we could do is take that out and we could decouple them. So now what we're going to do, of course, is we're going to put a little bit of stock. And put a little bit of stock in here, in between each machine. And we're going to decouple them. So now the costs start to build, because if you start to put stock into the system like that, now what you do is you string the lead time out. Now you start to get longer and longer lead times. So let's think about what you have to do next. Well, first of all, by the way, the first cost you're going to incur is the cost of stock, because this isn't cheap. You're having to spend money here. You're making products for no output to put that stock in place. That's going to cost you money. That's going to sit there constantly. Then, of course, you've strung the lead time out. Well, when you string the lead time out, what's the next thing you have to do? Well, you have to forecast. Now, when you've got very poor consistency on your processes, what's that forecast likely to be? Well, it's likely to be a forecast without accuracy, without certainty. Because when this is happening, you're at the mercy of chance. Your process might produce well, it might produce badly, and you have no idea what's going to happen day to day. So your forecast is usually pretty poor. Well, what does that mean? Well, that means what happens is you inadvertently put more stock here, because you end up with stock that you don't actually want. So now we've got stock building up in the whole system. So much stock, of course, that now what we need is some warehouse space. So here are the costs. Here's the cost of poor quality. Here's the cost of variability building on you. Stock, forecasting without accuracy. You need warehouse space. Because what you're going to do now, see, you haven't got room to have those sitting in between each machine. So what do? You have warehouse space. Now what have we got to have? Now I've got to have forklifts. Got to move it around. Well, I need drivers for that, so I've got extra people suddenly. We used to have just conveyors linking them all together, but now I've got forklifts. I've got forklift drivers. Oh, what else have I got to have? Oh, well, I need forklift licenses, because these days, not every old idiot can drive a forklift. So I need to put training on, and I think you have to refresh that on a regular basis these days. So we've got forklifts, we've got drivers, we've got training. Oh, because we've got forklifts, we need some space. We need space to store the forklifts. Yeah, so you could see the costs are starting to build. What else do we need? Oh, we got all this stock, haven't we? We're moving it into warehouses. Well, yeah, I really need a system to know how much stuff I've got in the warehouse now, to help me with the forecast. So we'd better buy a computer So we buy a computer so that we can count all the stock, and we can decide how much of it we've got, and we can make a better forecast, and we can come up with planning systems and all that kind of carry on. Okay, what else do I need? Well, if I'm going to buy a computer, of course, I'm going to need an IT department. So suddenly we've got IT skills on site. What else do we need? Oh, hang on, I'm going to need more HR people. So we need more HR staff, because suddenly I've got forklift drivers, I've got an IT department, so suddenly we're going to have to expand the HR department to deal with the paying of the salaries and looking after the pensions and all of that kind of stuff. What else is going to go on? Oh, hang on, because I've got a computer and an IT department and HR staff, well, I'd better build some offices for all the staff, hadn't I? Okay, so let's have a look. So I've built offices, I've got an extra warehouse, I've got extra space for the forklifts. Oh, okay, you know what I'm going to have to do? I'm going to have to heat all that space. So suddenly I've got heating for all of that. I've got a cost of lighting for all of that. Oh, I've got to make sure that the forklifts are in good shape as well. So maybe I'm going to need a little bit more. Maybe I'm going to need some more maintenance staff to deal with that equipment. Yeah, so maybe there's some maintenance staff needed as well. Now, you can see all of these costs building. Now, by the way, let's just point this out. None of them are direct. This isn't about looking at this process and going, I've got a man on this machine. You know, let's work out his OEE. How efficient is this guy? Yeah, which is the way we tend to look. We tend to look at the money-making process, and we tend to optimize the money-making process, and we ignore all of this. So often we're making these as good as we can, and at the same time we're making these as worse as we can. Well, there's huge amounts of overhead cost here. Now then, here's the thing about the cost of poor quality. Let's say I decide to take this a process at a time, so I'll go process A, process B, process C, process D. So I'm going to do a project here, and you say, okay, first thing I want you to do is I want you to work out the cost of poor quality. Now there it is, look, there's piles of it, millions of pounds in those costs right there potentially. However, here's the problem. Could I take some of this and assign it to this? Assign it to this variability? Well, actually, no, I can't. You could sit down with your accountancy people if you wanted to, and you could try and evaluate and say, well, this costs £1 million and there's 4 processes, so why don't we give £250,000 to this one, £250,000 to this one, £250,000. But that wouldn't make any sense. And you could spend months arguing about this. And when you present to the board, or you present to other people, or you present to outside people, they wouldn't necessarily believe that cost of poor quality was linked to that machine. But it is. It's linked to that variability. It's linked to the variability in the way the system works. It's all appeared because you had variability. You had poor quality. You weren't hitting 50 all the time. But you can't assign it. And here's why I don't try. The other thing is, of course, if you lose this, of course, let's say you do a brilliant job. Let's say you turn this machine into a super consistent process. Will you actually save these at that point? Well, no. That's the other problem. So even if you somehow manage to assign pieces of this to this problem, when you get rid of that problem, will you get rid of those costs? No, of course you won't. You know, getting rid of these costs will take you a long time. I mean, you could fix the whole 4-stage process and get them all to be consistent. Will you get rid of warehouse space at that point? Well, no, you've bought it, you've built it, you've got a factory that's too big. It could take you 2, 3, 4, 5 years before you actually get the money for this. In whatever way, you could fill it with You could fill it with money-making machines, make more money out of the same space instead of it being warehouse. But that could take a while to achieve. So here's my point of view about the cost of poor quality. Do I really want to spend? Do I want to spend weeks and weeks and weeks trying to get this right, trying to get a number associated with my project? No. Do I know that variability creates costs? Yes. Is variability the enemy? Yes. What are we going to do? We're going to find projects and we're just going to get rid of it. And probably we're going to get rid of the most inconsistent machines, or do the most inconsistent projects first. Because certainly when you start forecasting on an inconsistent project, not only have you got the obvious costs of poor quality, you've got even these are obvious, but you've got the things like you under forecast, then you let the customer down. What does letting the customer down cost you? You've no idea. You'll never know how much that's going to cost you. They could decide never to give you any more new business again, and you might never even know because they never speak to you about it. They could decide that you're still one of their best customers, one of your best suppliers, and they give you more work. You'll never know which situation you're going to encounter because it's at your customer. So there's costs of poor quality here that you can never ever evaluate. But variability is the enemy. Get rid of it all. And by the way, if you don't believe that this is true, here is a challenge for you. What I want you to do is to go to your factory layout. Take a look at your factory. It's going to be divided up into various departments and operations, yeah? What I want you to do is this. I want you to critically evaluate and say, okay, look, here's my factory layout. How much space makes money? And how much space is just storing stuff? Okay, just do that simple, critical evaluation. It is dead easy to do. And of course, what you'll tend to find, I would say when I do this, and I sometimes do this when I walk around factories, because you'll walk past a fire evacuation layout, and I can just quickly stop and look and say, how much of the factory is actually making things? And what you'll find is probably 25% is making stuff, 75% is storing stuff. If you're truthful with yourself, that's what you'll find, because what you've got is this stuff. You've got loads of cost of poor quality, but can you evaluate it and assign it to your individual projects? It is very difficult to do so. And if that worries you, if you're not comfortable with that, you actually won't make any improvements at all. Not make any improvements at all. It's one of the things that the Americans are obsessed with the dollar. They're obsessed with getting every cent out of every project. But because they can't work out every penny piece, they don't do nearly enough of the projects that they should do. Work smarter. Know that if you get rid of variability, you will get rid of the cost of poor quality. And ultimately, you will make more money. But you cannot necessarily assign every penny piece to every problem. And if you won't move forward without doing that, you'll just sit and you'll just have a process and a company that's full of cost and waste and the cost of poor quality. Understand that getting rid of variability makes piles and piles of cash.